Unit 5, Triangle Congruence, question number 5. So we're going to start with the homework help. So the first question says, what are the coordinates on the point on the directed line segment from negative 8 to 8 to 7, negative 8, partitioned into ratio of 3 to 2. So again, we have a point negative 8, 8, which will be here, and 7, negative 8, which will be somewhere down here. So we have our line segment, which has a starting and a stopping point, okay? And we're partitioning it into 3, 2, so 3 parts and 2 parts, so that means that it has a total of 5 parts. So we started when x was negative 8, I went from negative 8 to 7, so that would be adding 15, and we're doing 3 out of a total of 5 parts, okay? So 15 is divisible by 5 3 times, so we'd have negative 8, 3 times 3, so plus 9, equal positive 1. So that would be the x value, positive 1. So then the y value, we started at 8, and then we went from 8 to negative 7, so that means we went down 15 in ratio 3 to 5, okay, or 3 to 2, which is 3 out of 5. So simplify by 5, this would be negative 3, so we have 8, negative 3 times 3 is negative 9, so that's negative 1. So again, guys, that would be the result for where it partitions it. So that would be that coordinate right here. This isn't graphed perfectly, but that would be the coordinate. So the next one says, given the line, given that M and N are parallel, so M is parallel to N, okay, we need to find the value of XY. So what we're going to use is our various theorems or our various proofs, okay. So right here we have something called a linear pair. And we know a linear pair, so a linear pair means that when I add the two angles A and B, I should get 180 degrees. So this would be A, this would be B. So if I did 7y minus, oh well, we couldn't do that as yet. We can't do that as yet because again we don't know what the value of x or y is, okay? So I actually would have to use corresponding angles first. So actually this angle is in the same position as this angle, so this angle is also x minus 14. So then now I would have to use the linear pairs right here. So again, in this case, I'd use corresponding angles. So this is in the same position as this. So then here I would use linear pairs. Okay. So this would be A, this would be B. Okay. So I would say that x minus 14 plus this angle 2x plus 8 is equal to 180. So here I'll combine the x plus 2x, which is 3x. Negative 14 plus 8 is negative 6 is equal to 180. So add 6, 3x is equal to 186. Then divide by 3, so x is equal to 186 divided by 3 is 62. So x is 62. Okay. So now we're going to find the value of y using the previous linear pair. So I would say that 7y minus 15 plus x minus 14 is equal to 180. So we know x is 62. So we'd have 7y minus 15 plus 62 minus 14 equal 180. Combine. Negative 15 plus 62. So negative 15 plus 62 is 47. 47 minus 14 is 33. So we'd have 7y plus 33 equal 180 minus 33. Okay. So we'd have 7y equal to, so 180 minus 33 is 147. So then I divide by 7, so y would be equal to 21. Okay, so this is x and this is y. Okay, so let's try the next one. So it says the diagram below has where EF is parallel to BC. So EF is parallel to BC. Okay, If BC is 35, if ED is 24, and BE is 18, then find the length of EF. So find the length of EF, so let's call that X. Okay? So what we're going to do is that we're going to have one big triangle and then one small triangle that's in the middle. So my one big triangle, I'm going to draw it like this. And then my one smaller triangle, draw it like this. So this big triangle will be BD, BD. And then the right angle will be C. And then this smaller triangle would be EFD. So EFD. So they're sharing the same angle D. So these angles are the same, and we know that they're both 90-degree angles. Okay. So based on that theory, guys. So based on this, they have two similar angles. So based on angle, this angle also has to be the same. So based on angle, they are similar triangles. So based on angle, the triangle BDC is equivalent or similar, okay, to triangle EDF. Okay, so they're similar. Alright, so we're going to label our sides. So BC is 35. BD would be the sum of these two numbers. So 18 plus 24 is 42. And we don't know the base CD, but we actually don't really need it because EF is X, ED is 24, and since we know these two sides that correspond to one another, I could say that X over 24 is equal to the same similar side, 35 over 42, multiplied by 24, multiplied by 24. So X is equal to 35 times 24, because it's the same as 24 over 1, so you multiply the numerators and multiply the denominators. 24 times 35 is 840, and then 840 divided by 42 is 20. So X is equal to 20. Okay, so that means the line EF is equal to 20. Alright, so let's try the next one. So the next one says the figure below is reflected over the x-axis and then translated 5 units. What's the coordinate of the image point Q after these transformations? So Q is the coordinate -9, 1. So we're firstly going to do reflect over x-axis. Okay, so if I reflect over the x, that means that the y value stays the same, the x value stays the same, the y value changes. So Q complement be the x value stays the same, the y value changes, so that'll be a -1. Then I would translate right 5. Okay, so that means the x value is going to change, so that will be Q complement. Right would mean I'm adding, so I'm adding 5, so it'll be -4 and -1. Okay, so again, guys, just like that. So the next one, try to write the equation of a circle. So what do we need to remember? Well, we need to remember the general form for equation of a circle. Call R squared, where HK represents the center. Okay, R represents the radius. 2R is equal to the diameter, okay, which is the entire from one circumference to the other, so from one side to the other side. Then we also can remember area of circle is equal to pi r squared. Circumference is equal to 2 pi r. Okay, and that's the most things we need to remember from my memory so far. Okay, so we're going to write the equation of the circle. So we're going to have parentheses x minus something squared plus y minus something squared equals something squared. So the center point looks like it's right here at the coordinate 6, -7. 6, yeah, -7. So this would be 6, -7. So and then my radius looks like it's 1, 2 units. So the radius is 2 units. So because we're going from 6 to 4, so that's 2 units. So it'll be x minus 6 squared plus y, negative, negative makes that positive, so plus 7 squared equal 4. Okay, and if I wanted to find the diameter would be 2 times the radius, so 2 times 2, which is also 4. Okay, so again guys, just like that. So let's try the actual lesson. Okay, so the actual lesson has us doing proofs. Okay, so people don't really love proofs, so let's try to make it as easy as possible. So it says identify multiple missing steps and or reasons for the 2-column proof. Okay, so it says that we're given that angle B is equivalent to angle D. Okay, so it actually marked that for us. So it says angle B is the same as angle D, so we're seeing that right here. Then it says AD is parallel to BC, so AD is parallel to BC, so they're going in the same direction and they never meet. So prove that triangle ABC and triangle CDA are congruent. Okay, so this means congruent, or that they're equivalent, or they're the exact same. So we're trying to prove our aim. So our aim is to prove triangle ABC is the same as triangle CDA. That's our job. Okay, so we're given this right here. So what we could do is that we could realize that this line AC, they share this line AC. So both triangle ABC and triangle CDA share this common line AC. Okay, so this common line AC that we see right here is something they share. So step 2, after what's given, so this is what's given. So step 2, we could say that the line, step 2, the line AC, so the line AC is equivalent or the exact same as the line AC. They're the exact same line. And the reason that is because it is reflecting, alright, for both sides. If I was supposed to reflect this to the other side, it would still be the exact same line. So based on the reflective property. Okay, property. Alright, so what's the next thing that we could state? Well, we know that this side is the same for both triangles. Okay, we have an angle. Okay, so the next thing we can do is that we could think about this like a transversal. Okay, and if you remember transversals, so if you remember a transversal, they're parallel lines. Okay, that are essentially cut by another line. This line would be a transversal. So when you're cut by a transversal, you can actually form something called alternate anterior angles. So that means that this angle right here is equivalent to this angle right here. So if we see this angle is equivalent to this angle. So we could use that same theory, that this angle right here is equivalent to this angle, and we could say that this angle right here is equivalent to this angle right here. Okay, so again guys, those are based on alternate interior angles. Okay, so we could say that angle CAD, so we could say angle CAD is equivalent to angle, so again CAD is equivalent to angle ACB. Okay, and the reason is because of alternate interior angles, because this is on the inside alternate interior. Okay, so again we could use alternate interior angles, alternate interior. Okay, so again we could also state the other fact that the same angle right here, so BAC, so angle BAC is equivalent, so BAC is equivalent to DCA. Okay, based on the same alternate interior. Okay, so because they share, okay, an angle. So we could actually use it like this. So we say that angle side, because it's the same side for both. Okay, so because again, if we separate these triangles, so separate the top triangle, okay, and separate the bottom triangle, okay, we know this angle are the same, this angle and this angle are the same, and this side are the same. We could say that by angle side, so by angle side, these triangles are the exact same. So we could now prove the final thing, that triangle ABC is congruent to triangle CDA. Okay, so again guys, just like that, and that's how you guys do proofs. So let's try another one. Okay, so another one says, given that the line AD is congruent to BC and the angle D is congruent to angle C, prove that the line AB is congruent to the line BE. Okay, so in this case, we're trying to prove that AE, which would be this line right here, is congruent to BE, which is this line right here. Okay, so that's what we're trying to prove. Okay, well, we're given that these two angles are the same. All right, that's helpful. These lines are equivalent. Okay, so these lines AD is equivalent to BC. All right, so we know a side and an angle. Well, we also know that we have angles that are facing one each other, which are called vertical angles. Okay, here we had alternate interior, so these right here for alternate interior. Okay, these right here are called vertical angles. Okay, so anytime you have an angle opposite one another, right, they're called vertical angles. Okay, now we know that vertical angles are congruent. Okay, so that means vertical angles measure the same. Okay, so what we could do is that we could look at these like three triangles. So one triangle, two triangle, three triangle. Okay, and we could state that this triangle right here, okay, so we have a side, an angle, and an angle, a side, an angle, and an angle. That means these triangles are the same. So the first thing we're going to state, guys, is what we stated right here with vertical angles. Okay, we would say that angle BEA, so angle DEA is congruent to angle CEB. Okay, because they are vertical angles. Okay, so vertical angles are congruent. Okay, so after that, guys, we know that these triangles are the same because we know a side that they share, we know two angles that they share. So based on that, we could say that triangle so we could say triangle DEA, so triangle DEA is congruent to triangle CEB. And the reason why they're congruent is because of side, angle, angle. Okay, or angle, angle, side. Right? So side, angle, angle, or angle, angle, side. Okay, so or angle, angle, side. Okay, so in this case, now we're going to go ahead and try to prove that these two lines are the same. Well, because we know that these two triangles are the exact same triangle, that means that this side is also equivalent to this side because those are the same corresponding type sides. So we could say that this side is equivalent to this side as right here. Okay, so based on that, we could say that the line AE is congruent to the line BE, and it's because of the corresponding parts of a triangle. So CP, so corresponding parts So CPCTC. Alright, so I sometimes forget this. So it's the corresponding parts of congruent triangles are congruent. Okay, so again, CPCTC means corresponding parts of congruent triangles are congruent. Okay, so essentially if this side and this side are the same, okay, or rather if these two triangles are the same, that means this side and this side are the same, which means that they are equivalent to one another. Alright, so again guys, just like that. Alright, so what about the next one? Well, the next one, it says given that BD bisects angle ABC, or triangle ABC, so BD bisects triangle ABC, so technically there's a says BD bisects triangle or angle ABC, so it bisects angle ABC, okay, and then AB is congruent to BC, so AB is congruent to BC. Prove that the line BD bisects the angle ADC, okay, so it bisects ADC, okay. Well, essentially what I could use to prove this, okay, so what we could state guys is that this right here, so we couldn't state that these make a triangle, so I wish I could eliminate this, but we could eliminate this right here because I felt like it said that this was a triangle, not an angle, okay, so I thought I would gonna make a perpendicular, so let's eliminate this. I'm gonna redraw the triangle, the figure. Okay, and the bisect, and then these are the same. Okay, so in this case guys, alright, this line right here is the same line, so it says A B C D. Okay, so these lines are the same line because again if we look at it as two separate triangles, so where this side is triangle that goes like this, and then this side is this triangle, so this would be AB, this is D, and then this would be BCD. Okay, this is equivalent to this. Alright, they share this line BD. Okay, so because they share this line BD, that would be something called the reflective property. So we could say first that the line BD is equivalent to the same line BD, and that will be based on the reflective property. Okay, so then the third one would be the reflective property. So the third one would be, so because these are the same line, we could say that this, the same line as this, okay, I could now say that the angle, okay, again, these are two lines that are equivalent, okay, these are lines that are cut by a bisector. Bisector means that we're cutting it into two, okay, cutting it into half. So that means this angle and this angle are also the same. So these two angles right here are equivalent, okay, so that would say that angle ABD is equivalent to angle ABD is equivalent to CBD. Okay, so again, because of that, okay, I would be using angle bisected divides angle into two congruent angles, so angle bisected or angle bisector divides angles into two congruent angles. Okay, so that's what I would state for that one. Alright, and then the fourth thing that I would state, so the fourth thing would be that I need to prove now that they're similar triangles, that this triangle is the same as this, because we just proved that these angles are the same. So I could say that by side, angle, side. So triangle DBA is equivalent to triangle DBC because of side, angle, side. Okay, so because they're similar triangles, okay, we can now prove that these angles are going to be equivalent, because again, if this angle is the same as this angle, or these triangles are the same, that means these angles are the same. So this angle same as this angle. So now we could state that angle CDB is equivalent to angle BDA. Okay, and the reason we could say that is that we're doing the same corresponding parts, because if they're similar triangles, that means their angles are also similar. So our corresponding parts of congruent triangles are congruent. Okay, so then finally we can do our last thing, which is state that line BD bisects angle ADC, okay, because the segment that divides a large triangle into two congruent angles bisect the large angle. So again, we could say that segments that divide the large bisects the so segments that divide a large triangle into two congruent angles bisects the large angle. So segment bisect two large triangles bisects two large angles. Okay, I didn't use my space very well for this one. Alright, so pardon me for that one. So then the final one, guys, okay, so right here it says that AE is congruent to EC and BE is congruent to ED. Okay, prove that AB is congruent to DC. Okay, so we need to prove that these two lines are the same. So this line is congruent to this line. Alright, well, we know that these are vertical angles right here. So that's the first thing we know. So we know that angle BEA is equivalent to angle DEC, okay, because of vertical angles. Okay, what else do we know? Well, now we can prove that they're similar triangles because of side, angle, side. Okay, so now we could prove that they're similar triangles. So triangle DEC is equivalent to triangle AEB because of side, angle, side. Okay, so because they're similar triangles, that means that by parts of so 4, so then that means triangle or line AB is going to be equivalent to DC because of corresponding parts of a congruent triangle are congruent. Because if these are similar triangles, that means that their sides are also going to be similar. Okay, so again, guys, just like that. Use your space better than I did, please.